Hello everyone, this video is about email interaction in graph data modeling. In this video, we are going to learn about graph database using an example of email interaction. First, we are going to see an introduction in which we are going to learn some of the basic concepts which are required before moving further in the video. Next, we are going to learn about the cipher language, and after that we are going to see graph modeling, and at the last we are going to learn graph modeling using an example of email interaction, and we are also going to create a graph database using cipher language in Neo4j database. Now let's move further. Before moving going further, we must know what is a graph. A graph is just a collection of vertices and the edge, or simply saying a set of nodes and the relationship that's connected. Next is we must know what is graph data modeling. Data modeling is a translation of the conceptual view of your data to a logical view. The various building blocks of the graph are nodes, links, and properties. Nodes are the fundamental unit of our data. We design our entire model around these entities. Links are the relationship between the nodes. There are various types of links like single, directed, self-linking, or multiple. The properties are the descriptive characteristic of these nodes and the link. For example, a person date of birth. Now let's see the various graph model. The first one we are going to see is the labeled property graph model. It is like a more descriptive graph. A labeled property graph is made up of nodes, relationship, property, and the label. Nodes are contain the property, or nodes can be thought as a document that contains the properties in the form of arbitrary key value pair. Nodes can be tagged with one or more labels. Label group nodes together and indicates the role they play within the dataset. Relationship, it connects the nodes and the structure in the graph. A relationship always has a direction, a name, and a start and an end node. There is no dangling relationship. Now let's see using an example. Here in this example, vehicle VIN, policy ID, customer ID. These are all the nodes, whereas vehicle registration, vehicle year, customer phone, customer address. These are some of the properties of their respective nodes. Cover and owns are the relationship between the policy ID vehicle VIN and customer ID and the policy. Here we can clearly see that the relationship is directional, and covers indicates the policy ID which covers the vehicle VIN. Through this we can clearly see a labeled graph model. Now let's see another type of graph model, that is queuing graph. Queuing graph is a graph database that involves searching for a specific information or pattern within the interconnected nodes and the relationship of the graph using the query language. Here we use query language for various operations like creating database, searching, and etc. Major query languages are Cypher, SparkQL, and Gemini, but in our video we are mainly focusing on Cypher. Now let's see Cypher language. Cypher is an expressive graph database query language based on query and mainly composed of clauses. Cypher language is more similar like a SQL based language in database where we also use query to perform operation. Here in Cypher language we use mainly clauses to perform operation on our database like match, return, and update, etc. Now let's see these clauses one by one in details. Match. The match clause allows us to perform a specific pattern to be searched for in a database. Match is often coupled to a where part, which adds restriction or predicates to the match pattern, making them more specific. Return. This clause specifies which nodes, relationship, and properties in the match data should be returned to the client. Where. Where provides criteria for filtering pattern matching result. whereas create unique creates nodes and the relationship. The merge clauses ensure that the supplied pattern exists in the graph either by reusing existing node and relationship that match the supplied predict or by creating new nodes and relationship. Whereas set sets the property value. And one more clause is delete, that's remove nodes, relationship and the property. For each perform an updating action for each element in a list. Whereas union merge result from two or more queries. With clause change subsequent query parts and forward result from one to the next. This clause is similar to a piping command in Unix. Now let's see this graph database using an example of email interaction. Here we are going to create a graph database for an email interaction using the Cipher language. This is the graph database that needs to be created in our Neo4j. For this, we have written some of the query languages. First, we see what are the nodes and the relationship in this database. Email ID, user, these are the labels for the respective nodes. Here, this is the node, this is one of the nodes, and all this is a nodes for user, and similarly, this is a node for email, and many more. Here, to CC, BCC, Alice, sent. These are some of the relationships that are associated with the it. Here we can see that email is being sent to the Charlie. This this can be also thought as a single model in a graph where this is one of the node and this is another, and this is the relationship between these two nodes, and user and email are the respective labels for them. To create this node, we have written a query language here. This creates a node, and email 1 is the name or simply label. Email is a label for this email 1, and id 1 and content equal that is email content. These are the contents of this node, and these are the operation or the relationship between on this node. Bob sent email 1. This means that this email is sent by the Bob, and this sent is the relationship. And next is email 1 to Charlie, email 1 CC Davina, email 1 CC Alice, email 1 BCC Edward. This means that if this email 1 is being sent to the user Charlie and to the relationship, and email 1 BCC Alice, this is also a relations relationship between the email and the Alice. Similarly, email 1 and the Edward and email 1 to the Davina, and their relationship is BCC and CC respectively. Next, we create email 2 that and its label is email and ID is 2, content is email content, and here we have this is the node that is being created, and since it is a email, it must be sent by some user, then only it will be created, and that is Bob sent email to, means user Bob has sent this email, and it's that is email to, and similarly this email is been forwarded to another users like to Davina and BCC Edward, and similarly we have created email 3, email 4 and email 5, and their respective creators and their relationship to other nodes like send, to and CC. For example, we see one more ID 3. This is the email, and this is being created by the user Davina, that and it has been sent and to the server, and it is being forwarded to the user Bob and Edward. And similarly, we perform various operations like update, delete, and now we are going to implement the graph database. In this, we are going to implement the email interaction between users. For this, we are going to use Neo4j and Cypher language. To use the Neo4j, we can use either online version or offline by installing the app. Here in this video, I am using Neo4j online in browser. For this, we have to search for Neo4j sandbox and then log in and we can use. Now let me create the nodes that are present in the previous slides like email and others. For this we will write the code like this and it will create the nodes named as email and write its content and the relationship between them. Now let me execute this. It will take some time and let's wait meanwhile. Now it has been created and this is the graph. Let me zoom it. Yeah, this is the graph that is created. Here we can see that each relationship has been modeled as a separate graph, and one graph, this is a graph that contains all the nodes and present all the relationship also. Now let's zoom it and see. In this we can see the various email node and the user like Bob, Davina, Edward, Elise and Charlie and the email interaction between them. Here this number 1, 2, 1, 2, 3, 4 and 5, these are the emails, and we can see email 5 is sent as BCC to the Edward and the email 1 is sent to the Edward by BCC. Similarly, we can see other relationship also. Now let's see one of the another graph like this. This is a graph in which email 7 is related to other user how. Here email 7 is been replied to a user and it been sent by some user. Here we can see it clearly. Similarly, all the other graphs are as same. This is the practical implementation of the Neo4j. Similarly, we can write code like code to delete, update and others that we will see later on. Thank you for watching this video.